Good morning, everybody. We are the fourth team, and our topic is Das Storage, Nas Storage, and San Storage. We are Arana Rayón Leslie, Espinosa Santiago Luis Ángel, Lázaro Aquino Eduardo Alejandro, and Mayan Rodríguez Elizabeth. Nowadays, it's necessary to have a good storage to organize our information and data. So we have to take attention in the system architecture. If we understand how to build a cost-effective and high-performance storage, our system can save the money and we have our information safe.
DAS, Direct Attached Storage. What is DAS? It's the most basic storage subsystem that provides block-level storage and is the building block for another storages like storage area network and network-attached storage. A DAS system is directly attached to a server or a workstation without a storage network in between. The performance of a SAN or NAS is ultimately dictated by the performance of the underlying DAS, and DAS will always offer the highest performance levels because the connection is point-to-point with the host computer storage interface.
Characteristics. DAS is limited to a particular host and can't be used by any another computer, unless it's presented to other computers over a specialized network called a SAN or a data network as NAS server. A DAS controller allows maximum 4 servers to access the same logic storage unit, and protocols used for communication between computers and servers and DAS storage systems are FC or SATA or SCSI or PARA or SASA. Types of DAS. DAS is classified as internal or external based on the location of the storage device with respect to the host. Internal DAS. In internal DAS architectures, the storage device is internally connected to the host by a serial or parallel bus. The physical bus has distance limitation and can only be sustained over a shorter distance for a high-speed connectivity. In addition, most internal buses can support only a limited number of devices, and they occupy a large amount of space inside the host, making maintenance of other components difficult. Some examples are hard disk, ROM memory, and RAM memory. External DAS. In external DAS architecture, the server connects directly to the external storage device. In most cases, communication between the host and the storage device takes place over SCSI or FC protocol. Compared to internal DAS, an external DAS overcomes the distance and device count limitation and provides centralized management of storage devices.
Well, we have already mentioned some protocols that are included in DAS, so we're going to talk more about them. For example, the first is SCSI, that means Small Computer System Interface. That is one of the oldest forms of storage interfaces traditionally used in server or workstation class computers. SCSI uses a controller to send and receive data and power to SCSI-enabled devices like hard drives and printers. Since SCSI uses a low voltage differential bus, its speed and cable lengths are limited. Most recent versions of SCSI can handle up to 15 hard drives. While the cable sharing mechanism is relatively efficient, there is a maximum theoretical of 320 megabytes per second, but that limit is reduced further by SCSI overhead.
SAS, Serial Attached SCSI, is the latest storage interface that uses SCSI commands, yet is pin compatible with SATA. SAS cables can be 8 meters long, whereas the SATA cabling is limited to 1 meter. SAS is designed for the high-end server and storage market and can be connected to multiple hard drives through expanders, but the protocol used to share a SAS port has lower overhead than SCSI. Flash. Flash memory isn't a storage interface, but it is used for very high-end storage applications because it doesn't have the mechanical latency issues of hard drives. The benefit of flash memory is that it can offer more than 100 times the rate input-output per second and 10 times the great EOPS performance of hard drives, which is extremely valuable to databases applications. It has limited number of writes and rewrites, like 10,000 and 1,000,000 writes. To deal with this limitation, flash devices use a mechanism called word labeling to spread out the damage so that the device will last longer, but even that has its limits. Advantages. In a DAS system, the storage resources is dedicated, and besides the solution is inexpensive. The disadvantage was that DAS has been referred to an island of information, so the disadvantages of DAS include its inability to share data on unused resources with other servers.
I will talk about of NAS. Knowing like a network attached storage, NAS is a file level storage technology and it's built on top of SAN or DAS technology. It's called like a file server too. Usually NAS devices are operating systems that are dedicated to file serving. NAS units many times don't have a keyboard or display and are controlled and configured over the network, often using a browser. NAS systems contain hard disks arranged into logical and redundant storage. This technology removes the responsibility of file servings from other servers on the network. NAS use SMB or CIFS for Microsoft compatibility or NFS for Unix or Samba for both. The new NAS device will support SAN technology and you can create hybrid storage solutions using a general purpose operating systems like Linux or Windows using their own hardware. The difference between the NAS and SAN is that NAS does file level and SAN does block level, both in the network. For example, SAN is when the data is transferred across the network to the recipient in blocks directly, and NAS is when the file data stream is processed from the data blocks. NAS from the model needs an extra layer of processing, so the NAS processing may result in extra overhead, the processing speed, or additional data transfer across the network. This can be easily overcome with Moore's law. The overhead that cannot be eliminated has direct impact in many applications. Blocks level access can achieve higher performance and it doesn't need extra layer of processing in the operating systems. The benefit that comes with the NAS is the ease of the use. Setting up a NAS system involves connecting the NAS storage system to enterprise LAN, for example Ethernet, and configuring the OS on the workstations and servers to access the NAS filer. The many benefits of shared storage can then be easily realized in a familiar LAN without introducing a new network, infrastructure, or new switching device. The NAS device attaches to the LAN and provides shared storage resources. The NAS storage system involves two types of device, the client computer systems and the NAS device. The client application accesses virtual storage resource without knowledge of whereabouts of the resource.
In the client system, the application file access requests are handled by the client operating system in the form of system calls, identical to the system calls that could be generated in a DAS system. The difference is in how the system calls are processed by the operating system.
What is a SAN? It is a set of storage resources that can be managed and assigned centrally as needed. It's a dedicated high-speed network that provides access to storage at the block levels. SANs were adopted to improve the availability and performance of the application by segregation store traffic from the rest of the LAN. Allow companies to more easily allocate and manage storage resources instead of having isolated storage capacities on different servers. You can share a set of capabilities among several different workloads and divide them as needed. It's easier to protect, easier to manage. What is in a SAN? It consists of interconnected hosts, switches, and storage devices. The components can be connected using a variety of protocols. Fiber channel is the original transport protocol of choice. Another option is fiber channel over Ethernet, which allows organization to move fiber channel traffic over existing high-speed internet, convergent storage and IP protocols into a single infrastructure. Other options include Internet Small Computing System Interface, commonly used in small and medium organizations, and Infinite Band, commonly used in high performance computing every moment. Providers offer entry-level and mid-range SAN switches for ranked configuration as well as high-end SAN direction for every moment that required higher capacity and performance. The simple providers that offer SAN business products include Dell EMC, Hewlett Packard Enterprise, IBM, and Pure Storage. What is new with enterprise SANs? Storage providers continue to add factors to improve scalability, manageability, and efficiency. In terms of performance, flash storage is having an impact on enterprise SANs. Provider offer hybrid arrays that combine rotating disk with flash drivers as well as SAN all flash. In the enterprise storage world, flash is too far marking and runs into SANs every moment because the structured data workloads in a SAN tend to be smaller and easier to migrate than mass structured NAS deployments. Flash is affected SAN and every moment, but is mainly on the SAN side first and it's coming to the NAS side.
With this project, we could identify some characteristics of each storage, what are the types, and some protocols that they need to be used. Also, we can check the advantages and disadvantages of the storage. So now the new job is to decide what storage could be better for us. It depends the job that we are going to do.